Hello, I'm Calvin, and I will be showcasing my project, summer project. So the goal is to build a crane that could accurately move the arm. So the construction of the crane includes a U-channel for the tower, and I chose Go Blue the U-channel because you could fit a motor inside. And so I have a revolute made on this shaft and also this shaft, so I could turn this gear, which is mated to the shaft, and because I have a gear relation, the arm would also move with this gear. So currently the arm is upside down, which is not what I want. Okay, so on the arm I have 3 slides, but I only ended up having to use one, and they're driven by a pulley, which is actually bigger and much faster than this, and this is a 5-turn servo. So these slides are BWT link slides, which I put slider mates on them so they can work as like sliders in real life. But I also put limits on them so they won't break, so they won't fall apart and break in the on shape. And so for my calculations, I had to calculate the minimum torque to move for the motor to move the arm. So I first took the weight of the slides, which is 282.6 grams or 0.28 kilograms. And the length of the slides from the center fully extended is 900 millimeters. So the center of weight of the slides would be 450 millimeters or 45 centimeters. So the torque is calculated by multiplying the center of weight by the weight to get the kilogram point per centimeter. And to do that, I multiplied 45, which is the point of the center of mass, and the weight of the slides, which are 0.28 kilograms, and I got 12.6 kilograms per centimeters, which was the torque needed to lift the slides. Then I calculated one portion of the low side U-channel, and so it was 66 grams, so I multiplied 0.66 kg by 19.4, which was the center of weight, and I got 0.64, and then I also had to add 200 grams, and that was at the end, and the center of weight for that was at the very end, which is 90 times 0.2, which is 18 kilograms. And then I calculated for the other side. So for the other side here, the torque was 1.29 kilograms per centimeter, which is super low compared to the other calculations, and especially with the weight at the end. So the total torque needed was, so I added all of the torque for the items on this side and subtracted the torque on this side to get the total torque I need. And to be safe, I calculated the fastest motor I need is one that had over 100 RPM, around 100 RPM, so I chose the 117 RPM motor, Yellow Jacket motor. And so I also have the code for the arm. So the code uses PID, which stands for proportional integral derivative. And so I made a function that used the PID loop to slow down the arm as it neared the target position, which is given as a parameter, and the threshold is the margin of error. So it's the margin of error the arm will come into before it stops, and the KP, KI, and KD are used in the PID loop. So I realized after testing my loop with only setting the KP, I realized that the arm would spin faster and faster, which was not supposed to happen. It was supposed to slow down. And since I've done PID in the past, I've found out that that problem is often caused by the encoder being backwards. So I multiplied negative, so I made the encoder value negative, so I made the encoder value negative instead of having a positive, or else it will spin, so it can slow down as it approaches the target. And that was one of the biggest problems. And also, I used FTC dashboard to tune the PID for accurate results. So, throughout this project, I have learned how to make parts in Onshape because it was my first time using Onshape to build the robot. And also I learned how to calculate torque and optimize the speed of the lift, and also the minimum size I need for the pulley. And also, when building slides, I encountered a problem where one of the strings wasn't quite long enough. So next time, to ensure the string is long enough, I'd first rig the slide with uncut string, then cut it to the measured length. And while programming, I have found out a couple of problems and solutions. So, for example, if I want to get the motor to spin backwards, instead of setting it to reverse and then giving it positive power, I could just set it to forward and set it to negative power. This way, if I want to correct for overshoot and PID, I can just, it's much easier. And also for testing, I use the FTC dashboard, which at first I tried to open it using the IP, but I couldn't get it to open. And I realized I need to implement it into the code. And also on the driver station phone, I would need to activate it in one of the tall op modes.